Imagine if your twin went to space and then you became 4 years older than her. Well, that's time dilation. My name's Jane, and allow me to elaborate. Albert Einstein invented the theory of relativity. The special theory of relativity states that physical laws should be the same in every inertial frame of reference, which is stationary or moving at a constant velocity. But otherwise for non-inertial one, like something accelerating. It's like the faster an object moves through space, the slower it moves through time. This is where the General Theory of Relativity comes in. This theory puts into account gravity, and that objects can accelerate. For instance, massive things like our planet, warp space-time. How do we know this theory is true? Well, it has already been proven to be right. In 1971, two different planes traveled around the world, eastwards and westwards, each plane holding an accurate atomic clock set to the same time as the reference clock. When the clocks returned, they were no longer in sync. This is applied for things like a rocket. Entering Earth's atmosphere, time is slower above the atmosphere, but time is faster when nearing towards Earth's surface. All because of the strength of gravity. Time dilation can be calculated using the following formula. T prime, which is time measured from the observer outside the frame of reference, equals T, time measured from an observer within the frame of reference, over the square root of 1 minus v squared, which is the speed of the object, over c squared, constant speed of light. Another example to put this into perspective. Imagine an object falling from the sky. From our view, as an observer, the object is falling at a fairly constant speed. But really, when it is further above the Earth's surface, it is falling slower. But as it approaches the ground, it falls faster. Did you know that time slows down near the Egyptian pyramids in Giza? This is because of how massive it is. In fact, it is one of the most giant structures on Earth. However, the effects are barely noticeable. Now the twin paradox fits perfectly into all of this. It's when one twin goes to space and the other stays on Earth. Once the twin returns to Earth, the twin that remains on Earth would have aged more. This is because the space twin was moving at high velocity than the Earth-bound twin, meaning that time ran faster on Earth than in space when in a moving rocket, since the Earth's gravitational pull bends space-time. Do you know that all of this has to do with why we haven't been able to time travel yet? Well, we can't time travel because nothing can travel faster than the constant speed of light, mainly because there's no infinite source of energy to supply that. If something could travel faster, time wouldn't slow down, it would go backwards. What we know about space and time is just the tip of the iceberg. With commitment and determination, we will reach to the core of the answers. Thank you.